In this lecture, we're going to cover how to actually write reactive code using RxJS in Angular. By the end of this lecture, you're going to know which parts of Angular expose observables. You're going to know how to practically use RxJS with Angular forms. You're going to know how to chain commonly used RxJS operators together, commonly with respect to Angular forms. And you're going to know that you don't need to use observables in Angular and how to implement the same solution without an observable chain. So there are a few places in Angular where reactive programming and observables are in use. The first one is the event emitter. So under the hood, this works via observables. The second is HTTP. We've not covered this yet, but HTTP requests in Angular are all handled via observables. And forms, and specifically reactive forms. So reactive forms in Angular expose an observable, a stream of all of the input fields in the form combined. And in this lecture, we're going to use forms as an example of how to do reactive programming in Angular. And just a really important note right now, in order to teach you a practical example of RxJS in Angular, I've had to jump ahead and use something we've not covered yet, which is forms, and specifically the reactive forms module. Now this, what I'm about to show you, is not the only way to implement forms in Angular. This is the reactive model-driven approach. There's also the template-driven approach, and we're going to go through both of these in this course in a later section. Now we'll cover forms in much more detail later. But for now, I'm going to gloss over a lot of the details and focus only on the code that deals with RxJS. So don't worry if there's code that you see related to forms that you don't understand. We're going to cover forms in much more detail later on. In our example, we have a form app component here, which renders a form like the one you see on the right-hand side of the screen. We have a common input area, a name input field, an email, and a submit button. We won't be going over the listing for the template HTML. It's complex and won't make sense until we cover forms later on. But we will go through the code for the component class itself. Now I'm just importing them all right now just for simplicity's sake, but it's usually better just to import one operator at a time, and later on in the course you'll see me start just importing one operator at a time. But just to keep things simple, I'm importing RxJS Rx, which is similar just to the RxJS all JavaScript file. It's just all of the operators in one. Let me collapse down the HTML here to make it simpler. Okay, so we create a form property which will hold a representation of our form so we can interact with it from code. We then create individual instances of controls, and we add rules for when a user input is valid or invalid. So for the comment field, we've said it's a required field, so it'll only be valid if there's got a value in it. And for the email field, I've also said that it needs to have a pattern. It needs to match the pattern of an email address. Again, we'll go over all of this later on in the section on forms. We then use something called a form builder to actually create the form and link it together with all of the form controls. And in the end, we create a form instance on our component, and this instance exposes an observable, a stream of all of the input fields of the form combined into an object. Now it exposes that observable via the value changes property, and then we can subscribe to that observable and print out the current value of the form in our console. So value changes is the observable of the form. We subscribe to it, and then we're just printing out the data to the console. So now let me open up the console. Clear. Let's rerun our application. We look ready. Now let's fill out our form. So as I type into the form, you can see an object's getting printed out to the console. And the object represents the current value of all of the form fields. Each of those objects is something that's getting published on the value changes observable. But looking at the stream, we can see that most of the items are for invalid forms. So for instance, comment, either email is required, so this one is invalid. It's not only required, it needs to have an @ symbol, so all of these are invalid. This is a common issue when dealing with forms. We only really want to bother processing the results of a valid form. There really isn't any point processing invalid form entries. We can solve this by using another RxJS operator called filter. Filter accepts a function and passes to it each item in the stream. If the function returns true, filter publishes the item to the output stream. So this .form.valid is true when the whole form is valid, or false if the whole form is invalid. Now, if you remember from the fat arrow syntax, this is actually a shortcut for this. So the function we're passing to filter will return true if the form is valid, or false if the form is invalid. And if it returns true, then it's going to let this data item be published onto its output stream. So we're going to see it in our subscribe callback. If it's false, it's just going to stop that data item from being published to its output stream. So if the form is invalid, the filter function doesn't push items to the output stream. When the form is valid, it does start pushing items to the output stream. Let's now run the application and see what happens. Let's clear the console first. Now let me type into comment. Nothing's getting printed to the console because our form is actually still invalid. Again, for name, it's still not printing anything out to the console because it's still invalid. Email address, still invalid. As soon as I type in the @ symbol though, the email address field will become valid. And as you can see, we're publishing now something to our output stream, and we're subscribing to that, and it's getting printed to the console. So a comment box is a dangerous place. Hackers try to input things like script tags, and if we're not careful, we can open ourselves up to the possibility of hackers gaming our applications. So one common safety measure for comment forms is to strip out anything that looks like a HTML tag from the message before we post it anywhere, like before we post it onto our page. And we can solve this again via a simple map operator in our form processing stream. So we add another operator to our stream. Specifically, we add a map operator. We added this after the filter operator. So this map operator only gets called when the previous filter operator publishes to its output stream. To put it another way, this map operator only gets called on valid form values. The map operator gets passed the form object as a parameter called data. We apply a regular expression on the comment property to replace everything that could be a HTML tag with the empty string. And what we return from the map function is what gets pushed to the map operator's output stream. Now we have to actually explicitly return something here because this is a multi-line fat arrow function. We have to explicitly return something. We didn't have to type return here because this has an implicit return because it's on one line. Now if I rerun the application, and when I type something into the comment field that looks like a tag, so let me type script. In fact, let me type the rest of this stuff as well so you can see it on the console. So you can see something is being printed out which almost looks like a tag, but then as soon as I add the final arrow, it gets stripped out and the comment is then blank. So that's a really easy way with the map operator to do some very simple and basic form processing. Another useful feature would be if we could let the user know the last time the form was updated. So we can solve this again by adding another map operator to our observable chain. So we just add the current time to another property on our data object called lastUpdateTS. And now if we rerun our application, as well as the comment name and email field, we're also seeing this new lastUpdateTS field being printed to the console. So that's just a really simple example of how we could use RxJS and observables, and specifically reactive programming, with forms in Angular. But even though the form exposes a value changes observable, we don't actually need to use observables and therefore reactive programming in our Angular applications if we don't want to. Instead of adding operators to the observable, we can choose to just subscribe to it and do the processing in our subscribe callback. So I'm just going to rewrite the logic I've got here, just in a more imperative, non-reactive way. So now if I stop and restart, clear the console, we can actually see we've got exactly the same functionality, but we've written our code more imperatively than reactively. Now, in this example, there doesn't seem to be much advantage to actually coding reactively versus just coding imperatively and putting all of our logic in the subscribe callback. And that's because this example is just a really simple example. The advantage of RxJS and observables comes to play when we start using some of the more complex operators like debounce or distinct until changed. Implementing the same functionality as those operators via standard imperative coding techniques would take many more lines of code than the equivalent RxJS solution. To summarize, Angular exposes RxJS observables in a small but important number of places. We have the event emitter, HTTP, and reactive forms. We use operators to add to the observable chain and then subscribe to the output to perform real-life actions in our application, either changing the state of variables or calling functions. But Angular doesn't lock us into one method or another. We can choose to take advantage and code reactively, or we can just subscribe to the observable and code imperatively.